And we're live. Welcome back, everyone, to AJC and the Web Devs. We have a very special episode today. We have a new guest, never been here before, Robert. Really happy to have you. You're a GraphQL OG. You're working on some cool AI stuff. So why don't you go ahead and introduce yourself and let our listeners know who you are and what you do.
Awesome. Hey, folks. My name is Robert. Super pumped to be up here. I guess Dev and I go at this point in time way back, but it's the first time. No, it's the second time that I'm doing a stream with you. So I'm like really excited about this to keep
How
this
did
tradition
you meet?
going.
I was curious about that, actually.
React Miami.
Yeah, there we go. Yeah.
Oh, what year?
3 years ago now, I
24,
think.
I believe.
24. Okay. I was there in
Yeah.
2023.
Yes.
I loved it. It was really fun.
It's my favorite conference. I
It's
want to go
best.
one day as not well. The first time I went was not as a speaker, as an attendee, and that's the way to go. Because this year I went as a speaker, and I was just holed up in my room practicing right until the very end. So I got to miss all the really cool events. Oh well, it's all good. Yeah. So my name is Robert. Quick intro is that I currently work at Pinterest, where I'm on the web platform team. Before this, I was at Meta on the Relay team. At Pinterest, the primary thing that I've been working on is helping the company adopt GraphQL on web. And the big reason why that's not super easy is because if you start converting a screen to use GraphQL, you're not only fetching data in a different shape, you're also fetching it from a different endpoint. So you kind of have a couple of bad options. One is rewrite the whole screen, good luck. And the other is make more network requests, which hurts performance. So my marquee thing there at Pinterest has been working on the Relay migration API. Relay is a framework for building GraphQL or data-driven apps powered by GraphQL, which I worked on at Meta. And the Relay migration API essentially allows you to make components agnostic about where they get their data from. So you can start at the leaf and make the component not care whether it gets REST or GraphQL data, and then sort of build your way up. Once you get to the root, run some experiment and actually flip on GraphQL for an entire screen at once. And that's pretty cool because a lot of times you turn that on and you discover, hey, there's some missing logging on the back end, or performance isn't quite where you wanted it. So this is kind of nice. Yeah. Anyway, really excited to be on here. So.
No, that's super cool. We're gonna get deeper into GraphQL probably in the second half of the episode. I had said before the show, I'd be curious to hear your kind of coding backstory. I always like to know how people first learned to code. We've never met before. I was a boot camp kind of student. I originally had a music major and then got into all this stuff through later in life, in like my late 20s. And Redwood was kind of how I became into open source, and that was a GraphQL framework. Didn't use Relay, used Apollo Client. So I've said that actually the one GraphQL project that I never really went super deep into was Relay. I went deep into almost all of them, which is kind of ironic because I would argue Relay is probably the most important GraphQL project ever in certain ways. So I would definitely be curious to hear more about that from you. But yeah, so what was your first line of code, your first language? How did you first start programming?
I think I did a little bit of Logo. I don't know if y'all remember that one.
Heard of it.
The little triangle that moves around. But I think the biggest, I didn't really do all that much coding until I was, let's say, 22 or so, and I had my first job out of college. And it was building reports in Excel and doing them in PowerPoint and stuff like that, doing like market research. And I just ended up like automating a lot of my job. And that was awesome. Like I took something that used to take several weeks per month and like turned into like a 15-minute process, basically. That made me. No, I majored in math and stats. So I did a little bit like statistics programming and stuff like that, but like,
gotcha.
No coding standards.
Right.
At that point.
That explains the username.
Yeah. Yes, I think I got my statistics FTW Twitter account around that time. So.
Yeah, like what do you think of that quote? There's lies, damn lies, in statistics.
I think it's awesome. I think honestly, like statistics I'm very happy that I studied statistics. Even more so, I think, than studying math. Both are very interesting. I started out majoring in political science, and during my freshman year, I wrote one essay on the history of the Peloponnesian War, on the Melian dialogue, and like I used it 3 times in different classes, and I was like, oh, this is not fun. Like, but if you have the opportunity to get away with it, you do. And on the other hand, I took like this stats and poli-sci course, and it allowed me to like make these precise statements. Like my first introduction to like p-values and stuff like that. And I was like, this is so much cooler rather than sort of the airy, foofy world of writing that I had come from.
Yeah, no, that's super cool. It's a really interesting background. So just a little more on that. How did you get involved in Meta? Because I'm assuming you weren't hired to like do GraphQL, or maybe you were. How did that work?
I worked for a bunch of startups when I got into tech, and then I ended up changing and getting a job at Meta. I actually run Rust NYC, and I had presented about a framework that I built for building web apps where you write Rust and it compiles. I mean, it superficially looks like React, and it compiles into WebAssembly. And somebody from Meta was in the audience. I think they kind of pushed for me in the back. I don't know, but I got the job. Yeah, Rust.nyc is the I think that's our domain. Yes, that's it. You can find it. You can get access to the Discord there. We actually are associated with a bunch of other meetups at this point in time, like Rust Boston. We're starting a couple in Florida. We have some going in LA and San Jose. So like the empire grows.
It's cool. Let me know if you ever want to get a St. Louis one going.
Oh yeah, we absolutely would love that. And we can provide whatever support you need as well. I'm thinking like what would be really cool is to have a circuit where we basically share speakers, and if they happen to be in whatever destination, then we can arrange for them to have a meetup on relatively short notice.
No, I love that you are involved in the meetup stuff, because I used to do a lot of the Jamstack meetups. I mostly virtual, because I got into coding in 2020, so it was like the time to do online meetups. So I remember when I was like, I think it was September, October, November. I had like I would do. I remember one day I did 2 meetups in one day. Like I was like hit Seattle, and then I hit like Oregon or whatever. So yeah, it was an interesting time to be doing meetups.
Yeah, a lot of them like they didn't survive COVID. It's kind of sad. Yeah, I'm glad that we kept Rust NYC going. Less frequently during COVID proper, but like we kept it going. So to answer your earlier question, I joined Meta, and then you do this team matching thing, or at least at the time you do this team matching thing. And I ended up just
I've heard about that. They kind of give you try out a bunch of different groups to see where you would be best placed.
Yes. And I had one criteria, which was to join a team that used Rust. And so I would just sit there looking at the internal sort of GitHub tool, Fabricator, and looking at PRs that touch Rust files, and then looking up the person in the space view tool and being sad because everybody was in the Bay Area or Seattle or whatever. And then one day I found somebody who was based in New York. I was like, oh, this is awesome. I sat down next to him, like, I'm joining your team. And then he was like, you should probably talk to my boss. And so by doing that, I got on the team. And it was awesome. It was really, really high coding standards, and it was very difficult for a long time. And I was in the middle of onboarding when COVID happened, and I was like, whatever, I'll finish it in a couple of weeks. And then I sort of forgot about it. So I realized like a year later that I had gone through some amount of unnecessary pain and struggle as a result of having never completed the onboarding and never really just gotten from other folks on the team like, hey, this is how it works. And Relay is a fairly complicated framework. So it took a lot of just spelunking and learning. And I don't think I think now I would be much better at doing something like that, having done it once. But at the time it was a lot.
Oh, of course. Yeah. First time you do anything in your tech career, it's always so daunting. Like I remember when I first got my job, it was terrifying. I think I was so worried about every little thing I was doing, and now that we got like agents, it's you have so many better resources available to you.
Very true.
And even inside a tech company, if you're just like working on some sort of a feature or app team, that's different. but you're working on Relay, which is like a platform that's probably used by a bunch of different teams within the company, which is like a different kind of experience. And I think the way I first discovered you and your work through a talk at ReactConf, like reintroducing Relay, which I think was an amazing talk. And that kind of, I think the way that you kind of talked about those concepts, the way you introduced the framework, I think that caught my attention more than the framework itself. And I think over time, the like more talks that you have given, I think that's one of the things that I appreciate a lot about your talks and content, which is like just the way that you structure things, the way you explain things, and I think you put a lot of effort into them as well. So I'm curious when, like, how that happened, like how you kind of got into, I guess, like giving a talk about Relay instead of just like like writing some code for it, and maybe like did you kind of discover that, oh, this is something that I want to do more?
Thanks. I actually really appreciate that. I do try to put an effort into my talks. I think that some people are kind of amazing at giving talks. There's that one guy that comes to mind that does like I don't know if you're the most famous YouTube guy that does like a bunch of really cool things. That really doesn't narrow it down. No. I'm not talking about somebody like that. Somebody who does conference talks from back in the day.
For me, it was Rich Hickey.
Is that Dylan Betty who did the Art of Code?
No. There was one conference talk about like what was stuff like. It was from the perspective of the 50s looking forward.
Joe Armstrong.
I don't think I'm thinking of him. I'm thinking of somebody else, but I do like Joe Armstrong actually. Okay, whatever. There are just some people that have.
Like, I'm very curious if it comes to you. I want to know.
God, what a sidetrack here.
Yeah, no, this is great. Yeah. This is the kind of diversions I like, because I love conference talks, and I haven't seen your Relay talk, but I'll check it out after the show, because I've seen a lot. I've watched a ton of talks from those conferences, specifically those React, the React Conf ones. Like, when I first was getting into all this stuff, I was trying to get a sense of like what all these tools were. So I was going back and I was watching like all these talks, like Pete Hunt and like stuff like that, and that gave me a ton of context for what was going on in things like React and GraphQL and Relay, and like what are all these things, how they fit together. Because what I've said about the interesting thing about GraphQL is Facebook had this whole stack where they had React and GraphQL and Relay and Flux, like even before Redux. And then all those things were kind of broken apart and introduced to the open source world in a way where it wasn't clear that they were all supposed to be put together. And I feel like that made it really confusing for people if they didn't understand that all these tools were meant to be a certain part of a larger architecture.
Yeah. Yeah, so I guess to Dev's question, like I've been doing presentations for a long time. I remember in 4th grade, like being a bit of a class clown, like liking to do that. I did one where I pretended to be that Simpsons character. Hi, I'm Troy McClure, that one. Doing something like that. And I remember my parents being like, nobody's going to get this reference. And I'm like, you're not the right age for this. Like, yes, they will. And then I did speech and debate in high school. And I did...
you're a speech and debate kid. That's funny. I had a good friend who was a speech national championship.
Oh, fancy.
His name was Blake. Yeah. He went to the 2 big speech schools, Kentucky and the other one.
Okay. But yeah, I think like conference talks and talks in general, doesn't even really have to be conference talks at meetups. Like there are these super high value artifacts, right? I think a lot of people should be just putting more effort into them. And I also happen to enjoy it, so maybe it's easy for me to say. And obviously, like, therefore I lean into it. But I do like to give good conference talks. I think it's really, it does allow you to reach a different audience and more people. So for example, at Pinterest, when I interviewed there, sort of everybody that I interviewed with, not everybody maybe, but at least some of the people knew about some of my side projects and some of the conference talks I had given. And it coincided with, I had just gotten into GraphQL Conf. So I was about to, so that was nice. Like I got to just say like, hey, I'm about to speak here, which I think makes you look a lot better. Likewise, like when I said at Meta, like somebody in the audience had seen me. So I think that's cool. I think honestly, like it's worth it for folks to do it. Folks should do more stuff like that. And then in terms of effort, like I put a lot of effort. This summer I did 3 conference talks and it was too many. So I would not recommend doing that. I was very overwhelmed for a month and a half because of that. And that's why React Miami was so last minute. I was like in my hotel room until literally the moment of. But I would still recommend it because, yeah, it's fun. It's good. It's a great way to meet people. It's a lot easier to meet folks at conferences if you are a speaker, because folks will come up to you, or you have something concrete to talk with somebody about. You don't have to be like, so what kind of stuff are you into, and like try to find the overlap. Instead, you can just say like, hey, I like your talk about, I don't know, Redux or, TanStack or whatever. And then of course, if you're giving a talk, you want to talk about it, with other folks. I mean, at least most of the time. So anyway, that's my little spiel.
Nice. Yeah, I always feel like being a regular attendee at a conference is like the worst thing to do, because like it's like the worst place to be, even as a volunteer. Like as volunteers usually get free tickets to a conference, like they don't have to pay, but they still have like I guess like a access to more, I guess, backstage things and a better reason to maybe talk to people. Obviously, as a speaker, you have a lot more, like a much easier way, kind of breaking the ice. But I think maybe we can talk about conferences forever. We can also talk about GraphQL for a long time. I think we'll circle back to GraphQL, Relay, and Isograph in the second half. But yeah, I'm really interested in hearing what was your like early work with AI. What are the things that you kind of that you were excited about, that you struggled with, and how did you end up at Barnum?
Yeah. So I definitely knew about.
Getting some echo. It just
Is that coming?
Is it from my side?
It might have been. Yeah, it's gone now.
Okay.
Go ahead, Robert.
I'll put on my earphones.
Sorry. Yeah. Yeah. So I knew about Bitcoin in 2008, and then I looked at it and I was like, man, the Oracle problem, it's insurmountable. Like, who's gonna, Anyway, so I live with that regret. And then AI, I was very abundantly clear among my friends and I that like AI is going to change the world. Like, I don't know, a couple of years ago. I don't really know what the timeline is. But then I still like was more focused on Isograph and just getting very good at, efficiently making code changes manually. And then it really took until this year, which was months after sort of the winter of everyone using 4.5 for all their side projects, which is an eternity. I slipped and I broke my wrist. And so I couldn't type because I use an external keyboard and like it's very thumb heavy and I just kind of couldn't do it. And I ended up deciding at that point in time, one, my wife turned me on to Whisperflow, and two, I decided to try to use Claude Code for everything. So I sort of vibe coded my way into a way to use my computer entirely with one hand. So just kind of like a layer system plus typing plus like a custom keyboard layout. And also, it was really clear from doing that, like how much you benefit from infrastructure or from closing the loop, I guess people call it, and how important that is. Like I would have just like kind of dived in and started working and been able to maintain code quality if I was doing it manually. But like very quickly, the AI was just like dishing out slop. And I needed to just come up with this custom framework for essentially writing unit tests of key bindings and stuff like that. I mean, it's not really a custom framework. It was just like, really, it was just like explore this state space and make sure that whenever you make a change, it's intentional. And like, did the AI, I mean, it helped the AI, but it would still make these massive changes and not actually review them. So whatever. Okay. So after that, I did what everybody else wanted to do, I think, which is decide that I wanted to build a pipeline where one agent identifies refactors and then a bunch of other agents, maybe in parallel or something, implement them. And like the first times I did that, like it was just kind of bonanza. It was like kind of bananas. Like they would not commit their changes no matter how much I asked. There was like one file which was being used as sort of the just to store everything. And like, okay, so I had some pretty bad primitives, and like it would have been a lot better if I just like used a database or something for these tasks, which I did not. But it became very quickly clear to me that what I needed or what I wanted was this like a workflow and like a DAG. And so I ended up building this sort of like this JSON based workflow tool. And at the time it was using a bunch of agents which were long lived that would read from some sort of, that would call this binary and that would give them tasks whenever they were ready to have a task. I hadn't worked out how to run Claude-P quite yet. Plus I think like I was doing this mostly for work stuff. And we have like an interesting setup at work. And running Claude ephemerally like that was not one of the blessed workflows. So at the time I needed that. This turned into like a JSON builder pattern. So I realized that like it's just better to build this stuff in TypeScript. You have more type safety. Like the JSON stuff was very stringly typed. Like I could enforce the shape, right? But like if you're saying the next step is X, you don't really have any guarantee that X actually exists. So that turned into essentially a couple steps further into, okay, now we have this JSON builder pattern, but like what are we actually building? Well, we're building a workflow. Okay, so now instead of building the workflow directly, you're sort of building that's basically an AST. And that turned into, now we should execute this AST as if it's actually a programming language. And that ended up being Barnum. So the gist of Barnum is that it's a DSL in TypeScript where you write some stuff that hopefully looks like intuitive TypeScript. It looks a little bit like effect. That generates an AST that gets serialized and sent to a Rust process where it's executed or interpreted, I guess, maybe if you're being super persnickety. And on the Rust side, we execute the AST and sort of like schedule a bunch of async stuff and what have you. And one of those async tasks is invoking an LLM. And so the idea here is that Barnum has four, I think, goals is how I usually think about it. One is it should be really easy to invoke LLMs from it. That's kind of trivial. I mean, that's true of everything. So the three real ones are, one, it's kind of high level and focused on control flow and type safety. Two is that it makes it really easy to handle a parallel work and asynchronous work. And three, it is really easy for agents to write. Because ultimately, and I think if you have those three things, then what you have is the ability to essentially do something similar to code mode, the Anthropic thing that I guess was just a couple weeks old now, where the first step is you describe the problem or something like that, and the agent builds a program, and then that program is invoked, and it in turn calls a bunch of LLMs. And that is how you get to do several things. One is you constrain the behavior of the LLMs. So for example, if you're just asking an LLM, hey, one shot this feature, and there's 100 different sub decisions that you have to make, like, good luck. It's going to make bad decisions. It's mostly going to make lazy and easy decisions rather than really holding itself to a high bar. And secondly, it's going to be expensive because it's going to do stuff like list all the files in the repo. And then, let's say you have 1,000 files. Well, that's 1,000 files that are now in context, and then it's going to marshal those into a JSON thing to print out or something like that, right? Like that's like multiple times that these strings go in and out for no reason. And listing all the files in your repository, that's the kind of thing that you should be able to do just using, let's say, JavaScript. So that's the idea behind Barnum. It sort of allows you to constrain the agents, and by doing that, you have more reliability, and they're cheaper because you're not doing stuff that you shouldn't be doing with agents in the agentic world.
Awesome. There's one thing that I want to kind of talk about before we get into actual code examples. Could we define code mode? Dev, I saw you tweeting about code mode also. I've seen other people talk about code mode. I'm not up on this yet. I'm more of a Codex user than a Claude Code user. So enlighten me. What is code mode?
You want to take that, Robert?
No, you go for it.
I'd be curious for both of your takes. So.
Okay, the way that I think about code mode is basically that currently agents call like one tool, wait for the result, then they call the other tool. The best that the harnesses are doing right now is parallel tools, where models will write multiple, like 3 or 4 tool calls at once, then wait for all of them to finish, and then take the next step. Code mode is essentially a way for a model to write some logic that invokes a bunch of functions, basically uses tools as function calls within that script, and then which means it can also combine like control flow, loops. It can do like basic data transformation inside. So if you have a tool that returns 1,000 things, an LLM can just write like, okay, call this function and then do a dot filter and filter out everything that's higher than, or that's, like have some predicate basically. So instead of calling a tool directly, it writes code that will call a bunch of tools. And then one of those functions could be triggering a sub-agent. So within that workflow, it can do additional things. And the answer to why is that it's more token efficient. It's easier. A lot of tasks are pretty straightforward to like put together in a sequence. Like an LLM doesn't really need to do all the steps individually. It can just orchestrate them and only have to look at the final result. And honestly, right now, like I'm a heavy user of Hermes agent right now, and more than half of my Hermes tool calls are Python scripts, and I would love to replace that with actual code mode. That's my brain dump on code mode.
Yeah. So then,
Robert can fill in more details.
Robert, what I would be curious then to know is, so I hear a lot of things that overlap there. So what makes code mode different from what you're doing?
Yeah. Well, I can go and talk about a little bit about the differences, but I think that the key thing to answer the why question is that, like I said earlier, it's that if you are trying to get more reliability out of your LLMs, you don't want the LLM to be responsible for key things. So for example, if your LLM can skip unit tests, can comment out unit tests or whatever before making PRs and landing PRs, then at some point in time for a sufficiently large task or a sufficiently large number of tasks, it's going to start cutting corners. And on the other hand, it's fairly easy and sometimes really valuable to say, I would not like LLMs to skip unit tests. You should never commit something.
Be good if they just didn't do that. Yeah.
Yep. And the way that they can not do that is by having the LLM not be the outer layer. So right now, if you're using an agent to do stuff, then the agent is the outer layer and it can do whatever the hell it wants. Huge advantages to that. It's very flexible. It can kind of like adapt and whatever. But on the other hand, if you have a task that you know the outlines of it, and it might be make this change and then run TypeScript, even something like that, doing that as a in a programming language means that there's no agent on the outside that could just skip the TypeScript. Like, okay, maybe the agent could like modify the file and then, like hack the mainframe or whatever, you know what I mean? But like realistically, within the kind of stuff that it will do, it will not really, that prevents it from cutting corners. That's the most important one. Now you may think, that's fine. working with an agent directly is fine for all the things I want, all the things I do. And that might be true. It's actually most of the time for writing features, the proper way the proper thing to do is to work with an agent, because that kind of fits well. And you're reviewing the code at the end of the day, or at least kind of sort of looking at it. And if stuff is, if you have a human in the loop, then a lot of this stuff is not as high priority or high impact.
Because you're verifying it on a step-by-step basis, because you're seeing what it gives you. You're like, wait a second, you messed this thing up. You go tell it that. I will say an ad hoc way that I tend to deal with this is I just have an agent review another agent, but like not like you just have Codex review Codex. You have like Claude Code review Codex, or like, because then it will step outside of the context to actually review it. But that's still then they could cut corners in the review. So that gets me part of the way there, but it's not like a real way of solving the problem like you're trying to do.
Mm-hmm. Yeah. And so, yeah, so really it comes down to like, what situations do we want to remove the human from the loop? Okay, maybe you're doing some AI work as part of like an API, and you're just doing 10,000 refactors. Like those refactors might be converting a file from, I don't know, JavaScript to TypeScript or something like that, right? Like kind of annoying to do individually. Maybe there's a little bit of thinking involved. But by and large, like the task is well defined and not open-ended. So it's in situations like that where you want to use something like code mode, or Barnum, and both code mode and Barnum sort of fill the same niche, I guess you could say, and they make very different decisions on how to do that. But yeah, that's I think the gist.
Did we answer this? I don't know if we answered this question directly. Does this only make sense for background tasks? I'm not sure exactly which part of the conversation he's even asking about here.
I think I guess I think it makes sense if it's if it's something that's like there's no human in the loop, right? That could be a background task. It could be something that's part of an API. It could be automatically reviewing, if you're doing something like reviewing code in response to an event without any human in the loop. So I think the answer is yes, that background tasks fit for this. Maybe not only for background tasks, but yeah.
I think we can make it much easier to understand with a demo of some sort if you have that set
up. I was gonna say at this point, let's get into the actual, start looking at some code here. And also, I like that you said it's a TypeScript DSL, because that was the one thing that going into this, I was like, I don't know any other programming languages, so that will help.
Yeah. Actually, yeah, I think it's an on-purpose decision. On the one hand, like English sucks, or whatever vernacular you do sucks, because it's not composable. It's not clear what you're referring to. There's no equivalent of static type checking or anything like that. Like if you have an extremely well-written English language description of a task, you don't know that it is correct. And it is never 100% correct. You have to run it to see what happens. And even if it runs correctly, you're not 100% certain that it is correct. And okay, so instead of using English or vernacular, you should use a programming language. Why not use JavaScript? Well, JavaScript it's really hard in JavaScript to write correct programs. And in particular, the kind of stuff that you mostly want to do is it's kind of a DAG-like structure a lot of times. And in particular, efficiently going through a DAG of parallel work is something that JavaScript is notoriously poor at, a poor fit for. Okay, so why not use a completely different language? Haskell is really good at expressing that. Well, if I told you that you'd be better at writing AI if you wrote Haskell, that might be true, but also very few people would take me up on that offer. So the missing fourth option is a DSL inside of TypeScript that gives you different semantics, so it looks more like effect, but it is in the lingua franca, both the lingua franca for humans and also lingua franca for AIs. So that's why code mode writes JavaScript, I think. And it's fine, and it's great because there's a lot of adoption of code mode relative to Barnum. And that's fine, but I still think it's worse because of all the reasons that That's because it's just basically bare JavaScript. So you might, I for example, played around with code mode a little bit, and I asked it to do something that basically had like 3 phases. It would complete phase 1 entirely, then it would start phase 2, then it would do phase 3. But like sort of the ideal way to do something like that is to imagine that it's a tree and that there's like little inputs that go into all the thingies, and you just kind of work on whatever task is available. If you ask the agent to do that, maybe it will do that, but it will not but it doesn't naturally fall into that pit of success. And so you end up with these, you end up with a lower ceiling for the performance than, or rather it takes more effort to get good performance and stuff like that. And I think the point of AI is that the happy path has to be the performant path if we're going to start to use it everywhere and really unlock the benefits. Yeah. Okay. So that's mostly my responses to Parasocial Fix's questions.
You want to start sharing?
Thank you for guiding the conversation. Yeah. So.
No, good.
Yeah. So should I share my screen? Is what you're saying?
Yes.
Yeah. Okay. So let's do this.
And it's completely fine if the demo is if it doesn't properly work first time, or if it has.
You can also show like the docs page if we want to start talking about like concepts first, or you can go straight into the demo.
I need to enable sharing, so I will be back in hopefully a matter of minutes.
Sure.
We got a question here about beads. Have you ever used beads, Dev?
No.
This is like some orchestration tool. It gets you a bunch of agents kind of working in parallel. Beads sounds interesting. Parasocial, I've looked into a couple of those orchestration tools. I haven't taken the dive on any of them yet. But I feel like that's kind of where a lot of the stuff is going, is higher level abstractions to get multiple agents kind of doing stuff in concert with each other.
Okay.
All right.
Y'all see my screen? Excellent.
Yes.
Cool. So as you can see here, I haven't actually done a lot of stuff in Isograph for quite a while, but I created 3 PRs today. That's so productive. Oh my goodness. And
red X's.
Yeah. That's fine. These are not good PRs. The point is, all these PRs did was add a bunch of ePrintline comments at the top of files. And they're actually doing a poor job of this because I guess I didn't include to reset hard the repository or something like that, and it kind of like swallowed a few into it. Or some stuff was running in parallel. Who the hell knows? Yeah, this one only has 1 file. It's only supposed to modify 1 file based on the description. Okay, so this is our goal, is to make a bunch of automated refactors. Actually, I'm going to limit it to 1 file at a time because it doesn't really help. But like this runs in parallel by default. Okay, so I actually do this at work a lot. And one of the things that I've done is I listed something like 26 possible refactors that I think don't change behavior and are good to do almost in any file where we can find them. These could be simple. These are things like, I don't like the use of 2 pipes instead of 2 question marks, because 2 question marks is more clearly saying this is the default value. And so I have one description of a refactor that is that. Other ones are like, hey, there are some impossible states. There are some representable impossible states. Okay, so there's like a loading Boolean state variable. There's also a nullable promise value variable that's in state, and an error. And you can't have all 3. You can't have error and the okay value at the same time.
A quick question. So are all 26 of these ones you came up with yourself, or did you do an analysis also with the AI to help find them?
I think I just mostly picked the ones that I care about.
Okay, so you went through and actually wrote these all out to then direct it what to do.
It's both. One, I described them, and then I had the AI turn that into descriptions of the refactors to do, and then I would sort of read them and go back. I think the key thing to note is that you want to bootstrap what you're doing. you don't really want to write the code yourself if the code is code bundled. Like instead, you should just go back and forth with an AI, and then that will like expand that out into like exactly the thing that runs, and you sort of examine it, and you're like, hey, you made a bug here, whatever, and then you sort of go from there. Same thing is true of Barnum. Same thing is true of writing these refactors that we're gonna do. But yeah, there's like 26 refactors ranging from really small to actually pretty big changes to ones that sort of involve looking at many files at once. So for example, is every single prop that we have for every component like actually passed somewhere? And if not, can it be, are all the possible values passed? So are all the variants passed? So for example, we might accept a string, but it can only be 2 possible concrete values. One of the refactors will change that to the type, will make the type only those concrete values. Okay, but like the point is I've done that, and I've that way shipped hundreds. I'm not exaggerating here. I've shipped hundreds of PRs that just do that, and they have never, as far as I know, broken anything except for in one particular case where TypeScript was lying, and then I sort of updated the refactors to handle that case. And yeah, so that's kind of cool.
This is super interesting to me because I've been on this contract for the last like 7 months now, and I'm working for a very large payroll company to basically like teach their developers how to use AI coding tools. And I do a 2-week workshop for them, and like 3/4 of it is based just around refactors and like finding refactors and making refactors and doing exactly what you're talking about. So, and I think, and I've been doing that a lot on my own projects. So when I first read the description, it says like, this project is for like shipping hundreds of PRs a week or something like that. I think most people in their mind, they think, like 100 feature PRs. They don't necessarily think like this is 100 refactor PRs. And so I think the first question would be like, why would you need to make that many refactors?
The code base is large, and there's a lot to improve in the code base. Like, I think that there's actually, so yes, most people think about using AI to ship new features. And I think this is a poor fit for using AI to ship new features. Well, at least like the refactor part of it, because you're not doing the same task repeatedly if you're shipping new features. It's more like you're kind of ideating and figuring out what's the best architecture.
It really requires a human in the loop. Whereas what you're looking at, you're finding the space in which it can do a lot of this work independently of a human having to constantly, because if you had to check every one of these refactors, that's just completely out of the question.
Yes. And so I still use it for like making changes when I have a human in the loop. So for example, I had like 60 stacked PRs. It's 60, 70 or something like that, to refactor one of our main surfaces. And basically I wanted to break it up into smaller parts and do all the things that you would expect to do in a general cleanup of this thing. But that was very human driven. But in the end, like I had 60 whatever stacked PRs, and I ended up using Barnum, the second half of what I'll show you, to babysit those PRs, rebase them until they pass, and rerun the failed things that are flaky, and then essentially land them as needed. And that was cool because like that's actually, I'll talk about that later. But I think that the cool thing about that is that it's a convenient way to write it. And you'll look at the logic that's in the babysitting thing, and you'll see that, yeah, that like all of that stuff kind of makes sense. Like you do need to categorize the PR, and then you do need to do one or the others. And like writing that in English, like it won't be done reliably. And I did try to get LLMs to rebase PRs and land them for me. And like half the time it would just get confused about what the diff is and be like, hey, this PR is empty. Like, let me just close it. And then I would like, I'm not paying attention, so I wouldn't notice, but just some changes just wouldn't land. And that's silly. Like LLMs are bad at a lot of stuff. They're great at some things, but they're also bad at doing the thing that you need them to get right reliably. Yeah. So, okay. So there's 2 aspects to Barnum that I want to show you. One is the generating the PRs, and then one is the babysitting. And then I'm not going to show you the babysitting in actually, I'll look at the code, but we won't see it doing the rebasing because
all good. Yeah.
Whatever. There's no, the open source, there's no CI basically. Just as long as tests pass, I can merge them, and I usually merge straight to master. Okay, cool. So let's take a look.
You can continue on. I'm gonna just hop off screen for 1 minute to go refill my drink, but I'll be listening.
Yeah, cool. Okay, so here's Barnum. Barnum-circus.github.io for folks who want to check it out. Would definitely recommend it. The nice part about this is that there is a quick start, and if you just point the LLM at this quick start and sort of tell it that you want it to do that, it does a decent job of writing a refactor. And that's how I built, a Barnum workflow. And that's how I built most of these. Okay, so what does it feel like to write Barnum? Well, basically, you are doing something like this. Oh, this is actually, hopefully the current docs are up to date, because I want to be using the latest. Yeah, this is what it looks like. So for example, you call list files .iterate. For each of those, you migrate a component, and then you collect it, and then you run it. And what will this do? List files here is something that returns an array. We're going to iterate on that, and then we're going to call migrate component. That is something that takes an item in the array, and it's all fully statically type checked. What actually happens here? This generates a description of a program, an AST, that gets serialized, sent to this Rust process. That Rust process sort of executes it maximally parallelly. So this is a parallel iteration, for example. And then it finishes, and that value is serialized back to JavaScript. And when we await this value, we'll get the result of doing that. And then you sort of run this JavaScript like you normally would, and it kind of does the right thing. Okay, so what is list files here? Or migrate component? What is migrate component? Well, migrate component here is a handler. So handlers here are essentially just chunks of code that can do whatever they want. In this case, it doesn't really do anything. It logs something. And it says that it didn't migrate it. It's like kind of a useless little stub. But the point is, you can do whatever you want here. You can read the file. You can call Claude. You can invoke Codex, whatever. And so Barnum essentially allows you to glue a bunch of things like this together and do what you actually want to do. So let's take a look at Ref2, which is what I call the refactory, and take a look at process.
Did you increase your font by just 1 or 2?
Absolutely, I can.
That's great. Yeah.
I am blind as a bat too, and I appreciate it larger than that even for myself. Okay, so for example, we might call extraction consumer. Extraction consumer here is going to, it's going to loop, and it's going to find these refactors, and then it's going to put them in a queue. And let me actually dive into what this actually looks like when I run it. So if we take a look at Ghosty, okay, so first thing I'm going to do is I'm going to clear the state out of this thingy, and then we're going to run it.
Your font on your terminal now.
Yes. Okay, and now I'm going to run it. So I'm just going to invoke some sort of JavaScript, and this happens to end up invoking the pipeline. But like, there's like, it's whatever. It's a CLI. It does some other stuff. And I point it to these refactors, and this is literally how I use it at work, and also how I'm going to demonstrate it here. And we're going to run it. And what is this going to do? It's going to reset the queues. All this logging, I'm just doing myself. It's just calling functions. And then Barnum sort of queues them together. And when it gets going, I'm not sure why it's taking slightly longer, it's going to start invoking LLMs. And one of the things that it's going to do is, for example, well, I'm just sort of very verbosely logging the heck out of all this stuff. And you'll see that like one of the things the LLM said is, hey, the refactor has been successfully applied. All 7 print line statements have been inserted and blah, blah, blah. Okay, cool. So it's actually doing that. So
it's logging back its own chat responses.
Yeah, exactly. I just happened to do that. So
yeah,
nothing
well,
about
makes
this
sense
is really
because if you were vibe coding this project itself, you would want those logs to be fed back into your agent that is creating the project
yes.
itself.
Yeah. So really all I'm doing is, let me see, is call it -p maybe? Is that what you're supposed to do with Claude? Is it Claude -p? Is that what we do? Yeah, here we go.
Yeah, for programmatic access, yeah.
Yeah. I'm literally just doing this. I'm writing some sort of file, and then I'm executing that file. And that file happens to contain Claude-P. Okay, when I execute this, I take a look at this and the output, and then I stream it to standard out. So it's like nothing, and not really anything special.
It's a CLI, like you built a CLI.
Yeah, just,
Again,
yeah,
this
right?
is great. This is everything I'm building right now. The AI is exactly like what you're doing right now. It's exactly the type of crap I'm building, which is the CLI piping all this different stuff together.
Yep. Okay, so I don't actually usually log this amount of verbosity because it's kind of ridiculous. But like the point is, it does a bunch of stuff, and then eventually this will finish. This is sort of the extraction part. Wait, no, this is implement now. So now it finished extracting the refactor, and then it will implement it. And cool, it created a draft PR here, and let's take a look at this.
So can you explain what you mean? Sorry, go ahead.
I was gonna say, so does this have like a GitHub token, or like you have it given permissions? Like, how is it connecting to? Or I guess Claude Code is just doing that.
Claude Code is just, well, no, I'm just calling GitHub or GHPR create or whatever, essentially invoking
you're
some
running
script.
the GitHub CLI also.
Probably,
Okay.
yeah.
Great.
I say probably because again, everything is sort of bootstrapped together with me and the agent working together.
Yeah.
So excellent work. It created a perfect PR doing exactly what I wanted it to do. It's very, very impressive. So actually, let's take a look at
Dev, before we continue on.
Yeah.
Sorry, yeah, I was just wondering, what do you mean when you said extract a refactor before implementing it?
Sorry, that is, why does this not what I mean is that there's one process that loops over a bunch of input files. So we have these input files. There's only one here in this input. Normally I would have every single file in the repository. There's one process, one thing that loops over each of these files, analyzes them for potential refactors. So in this case, this is the refactor. I don't know how to do word wrap. No, it's not there. But like, it says add ePrint line. And I basically send this to Claude, and then I have a whole bunch of stuff around it. So for example, at work, I don't actually know what happens here. This was Vibe adopted in order to work with Isograph. Like at work, I have a bunch of stuff that it attempts to run. So for example, make sure that TypeScript passes, make sure that lint passes, and so on and so forth. And then there's other agents that will re-review it to make sure that nothing is in a broken state, or we didn't cut any corners and stuff like that. But I'm being a little bit vague here, right? Because the point is, like, it's a programming language to do whatever the hell you want, and I just happen to be doing that. But I think that the bigger point is, like, what actually does it feel like to do this? Oh, okay. So let's see. Reference.
Also, I wasn't seeing these comments in the chat. I think we kind of answered this. How do you actually drive the LLM? You're doing it via the CLI agent, not via the API.
Yeah.
You say it's called soft wrap in Z.
Oh, I think I might be looking at an old version. It's okay. Okay, soft wrap. Thank you. Oh, wonderful. I just started using Z and Ghost TTY on. I figured it's time to upgrade. But yeah, essentially what I'm doing is this. When I run the CLI with process, right? Or when I run it, I'm running this, and this calls run pipeline. I think this is outdated. It should just be not run. But I might be on an old version. I guess I probably just haven't pushed the latest.
The minutia is not super duper important.
Fair. Okay. So, and then this will run this thing, and then it will run this thing, which is the second thing here. And this one will run these in parallel. And the extraction consumer and the implementation consumer we were just talking about earlier. So in particular, the extraction consumer will loop. it will dequeue a file from the queue, and if it finds a file, it will run this sum branch. If it doesn't, it will just sleep, and then it will recur. But it probably shouldn't, because if you're done with files, you're done with files. So I think that's like, we probably don't need to have this outer loop, but this is a loop.
So I was going to ask about the loop. So because everyone's talking about loops right now in the AI world, so is this leading into that loop-based workflow, or is this an incidental loop? This is not super important.
I have opinions on how loops are done. Like, loops are a very simple primitive, and it's bananas to me that Claude is like, hey, you can run stuff in a loop. And it's this amazing feature. When we have programming languages that have loops, they have many types of loops. They have loops with conditions.
I love that.
It's just kind of weird that we're like doing that like loop and goal are these like amazing primitives. Like, this is silly. Like, programming languages are just better ways of expressing that. And if that allows you to corral the logic that the LLMs are doing into sort of like subparts, and thus get more reliability and so on and so forth. You just don't need this stuff in LLMs. Anyway, so I think that's my overall opinion here, is that this is a better way to write things. Okay, so what do we do? Dequeue file. Okay, nice. GD does go to definition. That's not that bad. It's a handler, like we just described, which is, say, it just does some arbitrary stuff. And in this case, it probably looks at the list, like some folder of files, and it kind of uses that as a queue. And then if we find one, then yeah, I'm pretty sure I have an updated version of all this stuff that looks better. And so this whole time I'm going to be trying not to talk about how I accidentally
do you want to take
the wrong version. No, it's fine.
It's
fine. It's fine. No, it's fine. It's fine. Okay, so and now we're just sort of like describing some sort of workflow. So we get this claimed file. It's a reference to essentially something that has this shape. We don't ever get this shape in JavaScript. This is like all on the Rust side, and the Rust side will call this kind of stuff, and it will do this, and then eventually we'll loop over each of the refactors. And we will essentially call this thing, and this will, sorry, I'm going to make this slightly smaller because I'm very bothered by the, there we go. Okay, at least it kind of looks a little nicer now. Is that still big enough for folks?
That's perfect, yeah.
That's good.
Okay, cool. Yeah. So it'll bind this, and then what do? We'll call extract refactors and extract refactors. What does it do? Well, it reads the file, and then it calls Claude, and it expects some sort of array value back. But that's not really what's important. What's important is that this thingy will make sure that you have that Claude returns this schema of some sort of JSON that returns this Zod's, that upholds this Zod's schema. And so, okay, so that's going to be something like refactor name, what locations to change, a change summary, a motivation, guarantee. I don't even know if like this is necessary. It's like maybe just these would be necessary, but whatever, it's all vibe coded and it works. That's the important part. And okay, references, find all references, G Shift A. Man, this is like weird. I'm still learning.
You can just have your VS Code keybinds instead, if that's what you're more familiar with.
Yes, I have a lot of custom keybinds. Okay, you know what? I'm already lost. Okay, so we extract the refactors, right? And that gives us an array of items, right? And then we're going to call advance or finish. So this is another handler, and I think it seemed to have changed something or other somewhere, because now everything's, let me just try undoing things.
Like it's a relatively small amount of code for the overall project.
Yes. And the point is, okay, so I mean, I could continue running through this, but like it's not really like particularly interesting code. It like does what you expect. Conceptually, we have a list of files. We have a list of refactors. We create a cross product of those. For each of those, we run an agent to say like, hey, please read this file and tell me whether this refactor exists or whether any number of these refactors exist in this file. If so, generate essentially a set of instructions. And then somewhere later, this will advance or finish, blah, blah, blah. And then we will get to, let me find
references. Okay, so I'm totally with you on all of this. My one big question right now is you mentioned that it looks at a single file for these refactors. That seems like it would be fairly limiting then in terms of the overall types of refactors you could do.
It focuses on one file at a time, but it's an agent. It can do sort of whatever it wants. So it will read other files.
A bunch of files all at the same time.
I guess
I just look at it this way, like a common refactor you might see would be like an overly long file that needs to be broken up into like 5 modules, something like that. So is that the type of thing it could do, or
yes.
that is just
it can.
It can.
Yeah.
Okay, great. That was my big confused part here. But
I think one other example to maybe explain what maybe Anthony was trying to say is, let's say I have a file and it imports like 3 other files, and to determine if a certain refactor is needed, I also need to go and look at those 3 other files. But I might also have maybe I have other agents looking at those files as well. So I guess, again, because you're just calling Claude here, you can just prompt Claude and ask it like, hey, does this file need this refactor? And Claude has the read tool, which means it sees the file and then it can go ahead and read other files from the code base, and it can easily figure out that, hey, this is needed or this is not needed, basically.
Yes.
Was right.
Yeah, and then my follow-on question from that is that what are its heuristics in terms of what requires a refactor versus not? Because it's a slightly subjective thing.
I think those things would be like things that you explain in your refactoring description. Like these are the decisions.
Right, because you're starting by explaining what the refactor has to be in the first place, so it doesn't have to make that decision. Gotcha.
Mm-hmm.
Yeah, exactly. It's just like in practice, these extraction instructions that I have are sometimes really short. Like the question mark, the 2 pipes to double question mark, pretty simple. It's like change it always, make sure it doesn't change any behavior. If the left side is a string that could be empty, like be careful, whatever, that kind of stuff. And other ones are like multiple pages of descriptions. So for example, I have some that essentially adopt the Relay migration API, which is kind of akin to adopting Relay. And that's like, it's multiple essays worth of like, here is the correct pattern. And if I could break that up into smaller parts, I think it would have been worth it. But like right now, I think the best way to use Barnum in its current state ends up being a very detailed description of exactly the refactor that needs to happen.
Yeah, I'm also getting the sense that these refactors are not just simplifying your code base. They are like you're talking about bringing on GraphQL versus not, which is like that's a different type of refactor from like I'm trying to cut down on tech debt,
Yeah, exactly.
Yeah. One example that I'm working on right now is like I'm trying to migrate a bunch of Solid.js projects to Solid 2.0, and there's like a bunch of RFCs that
really
explain
good for
the
that,
API.
Actually.
Exactly, yeah. Because the some of them are like simple enough, like you just rename a function and it mostly does the same thing. But some, like there might be a few cases where just renaming the function is not enough and you need to do additional things. And there's a few APIs that have completely changed, and so some of them have like a really complicated decision tree almost, and you have to look at a bunch of files. So obviously, if I take all of these RFCs, dump it into a single Claude session and say, go and refactor this app, I don't expect that to work in a million years. Maybe Mythos can figure that out.
I've tried that. You're correct.
Right.
It didn't work.
Exactly, yeah. But and this is kind of what I eventually landed on, was that take like a bunch of individual refactors that need to happen, and kind of explain like different scenarios in detail, and then split them across different Claude sessions or different like LLM sessions. Like, okay, I am going to run one session that just goes and looks at all the create effect usage and just marks the ones that need to be migrated or that need to like how they need to be migrated, and then have a different session that then goes in again and actually does the refactors. So there's like a lot of different kind of optimizations that you're doing. The first is that you're giving agents a very specific task of like looking for one kind of refactor or one kind of pattern. And then the other thing is you're kind of splitting the concerns of identifying an implementation, because if you have the same the agent that goes and identifies refactors is going to have a lot of files in its context that don't need to be refactored, because it's like its job is to filter them out. So the agent that goes ahead and implements them, it's not going to have any of that in context, and it's going and I think the thing that we know about LLMs is that the less context we use, the more performance, or like the more correctness we can get out of them. And obviously like cost, like instead of like a 200,000 token sessions, you can be done like you probably are going to have like 100-200 agent sessions, but if all of them are like within 50k tokens, then it's probably much cheaper than like letting Claude keep going on a task and compacting, and then hits 200k again, compacts, hit 200k again, which is the worst way of looping, but that's the only way of looping that people have kind of been advertising so far, because the people who are advertising looping are model providers.
Yes, actually, that's a really good point. I missed that earlier when I was talking about the litany of advantages, is that because you can essentially tailor the invocation of Claude to something very narrow, it's literally read this one file and tell me whether this applies and return something with the following JSON shape. Like that's as like minimal. One, it's a good use of an agent, because the agent will code mods, stuff like that, kind of difficult to use for something more complicated. Okay, adding like an ePrint line in the beginning of every function, like, yeah, we could do that with a code mod. But like anything more complicated than this, then an agent is the perfect thing for it, but you also want to use it in as narrow and tailored way as possible.
This is something Parasocial actually said a while back, was remember code mods, a whole industry that just died because of LLMs. Yeah, I remember code mods were a big thing for Redwood, because we would always want to create a very smooth upgrade path. We would give all these code mods to upgrade your stuff, but it's just very complicated.
Yeah, so to answer your question earlier, so we can basically do whatever we want. And if we wanted to just read the one file, well then, just change the allowed tools that you pass in. And again, like this is not some magic API. It's just something I wrote, which ends up invoking Claude, and you can sort of do it however you want. But what's nice about this extraction is it can't write any files. It can't do other stuff, at least potentially. I don't really know whether I think it will not do other stuff, at least hopefully. So that's kind of cool. Okay, so we extract the refactors, and then what we do is we put them in another queue, and then we call this implementation consumer, and that does sort of the reverse of that. It reads from that queue and implements and generates a PR. And that's sort of more of the same. And I think the more interesting thing to look at is actually just this babysit thing. So for example, again, hoping that this is good. At some point in time, we need to process one PR. Let me see where this is. How do I? Yeah. Okay. Cool. And that is that is called right after categorize PR. So categorize PR it's essentially a handler that returns some sort of man, I don't know how to. I still don't know how to go to definition. I didn't work though. So we have this PR category schema, right? Okay, so the PR is going to be categorized in one of 5 things. Bypass automation. Okay, if I need to force land it for some reason, or it has been force landed, it needs to be retargeted.
What do you mean by
because
force landed?
With internally at Pinterest, we have some tags that you can use to force to skip CI. Okay, the point is like that's not that doesn't matter.
Force
force.
Yeah, exactly. Okay, these are the ones that are more applicable. Okay, so maybe this is a stack of PRs, and now this PR doesn't point at master. It points at a branch that is either landed or has been abandoned. So we need to retarget it. We need to rebase it and then change the PR to target master. Needs rebase. Okay, there's more than one commit in this branch, and we need to rebase it. So the parent commit has landed and been deleted. Some sort of checks are failing, or it's ready to merge, or some sort of checks are still pending. So there's like canonical things to do, right? And what do we call it? Categorize here. So what do we do when we categorize the PR? Well, okay. I mean, it's the kind of thing that you would expect. It's just some JavaScript function that's in a handler, and it does whatever you want. Like it does things, and it returns values, and it checks if there are conflicts, in which case it needs a rebase and whatever. The actual stuff here is not super interesting. What only matters is that if I can find it, hopefully. I don't really know how to. I guess I could look for references. Find all references. Oh no, it's create handler. I didn't want that. I wanted to categorize PR. Yeah, okay, so here, and then we ultimately call process 1 PR, right?
So does categorize PR call an agent at any point, or is it all just procedural code?
I think that one probably doesn't invoke an agent.
Right.
Yeah.
Okay. So it's also a good showcase of like a lot of times you can take a lot of work out of the agent's kind of plate.
Yes.
When you can just like, if it's simple enough and you can express it deterministically, then why the hell not? Like, why would you give an agent a task?
Answer. So obviously you want to do that if you can.
Mm-hmm.
Yes. And then we process 1 PR, and this has this fix failing checks pipeline, and that does that invokes an agent that will essentially look at what checks have failed, preload those into context maybe, and then tell the agent, hey, here's what happened, please fix it. And then actually we might as well go to the definition of that. So what is this going to do? It's going to check out the branch. It's going to run fixes. And if it passed, okay, actually, I do have a retry loop. I'm really on an old version of code right now for some reason. That's fine. This actually just loops some number of times and then retries. And what's nice about this is that that's the kind of thing that you want control over. I limit the number of retry attempts to something like 3. Because if they have failed 3 times in a row, it's probably something is not going to be solved by throwing more tokens at it. And the PR gets in this like sort of parked state where the agent just stops trying to fix it. And otherwise, it will commit and push the branch. And that, as you might expect, just does a bunch of stuff in like, sort of deterministic land. But yeah, the reason I wanted to talk about that, about like babysit, was exactly like Dev said, like the more you can move into the deterministic world, the better. And also to just simply point out that categorizing a PR into those 5 things and handling each of those distinctly would be a nightmare to express in English. And on the other hand, it's actually quite nice and easy to express in what sort of amounts to a functional language. And that is a huge improvement. But then you want somewhere inside of this to be able to invoke an LLM. So the moral of the story is that the outside should be a programming language, and that invokes LLMs on the inside. And those should be as simple and as light as possible.
Yeah, makes
so that's
sense.
Barnum.
Yeah, oftentimes with agents, like there are conversations about like inner loop and outer loop, and yeah, what you're trying to say here is that a lot of times humans are the outer loop. If I'm using Codex or Claude directly, I am the outer loop. Every time the agent does something and stops, I have to look at it and then go and trigger another session, which like basically I am the bottleneck of how much work is happening, how many tokens I'm spending. Um, yeah, you're not sorry if yeah, but if that outer loop is something you can orchestrate, you can loop and you can keep like run over and over again. uh it it gives you like a higher level primitive to define what kind of work you want to do. uh I think this is kind of what Boris was talking about when he said that he doesn't write prompts anymore. He writes loops. But I think what people miss is that like a part of the loop is writing the prompt itself. So writing a loop doesn't mean you're not writing prompts anymore. It's just that you're writing prompts in a very different way where they describe a very specific small amount, like a unit of work, instead of like a high level go and do this thing.
Yes, I think that's exactly right. Like, yeah, it's like we wanted to describe these workflows. Describing them with English is not going to get us to the reliability where you can actually remove humans. But ultimately, what we're doing is describing these workflows. And I think that like people call that building loops, which is kind of silly, but yeah.
Yeah, I think one thing that I would love to get maybe if some of your thoughts on is like I saw somewhere a while ago that like agent orchestration is going to become like a concurrency problem, and I think this was kind of obvious in some of these workflows when there was like a queue and you have to acquire a file, because if you have a bunch of things running in parallel on the same code base, it's basically like running multi-threaded programs with shared memory. Like there are a lot of similarities. This is why worktrees are an important concept, because uh, it's basically like forking memory, so that different threads can. I actually don't know too much about concurrent like multi-threaded programming and how that works. I'm more of a like just have every thread just have its own little piece of state and then serialize messages back and forth, like kind of the Erlang model. Um, but what I saw a decent bit of in Barnum was like there's a queue and you have to acquire resources, and so how like what does that kind of look like? Like how often are you doing work trees? Where are you implementing work trees? I think that also becomes like a thing. Like how many work trees do you have at the same time for any project? Yeah.
Yeah. So everything is sort of done in userland. Like Barnum provides some like low-level primitives, but like it doesn't have a strong opinion on this sort of things. However, you're right that like in practice, you do want to, well, actually, it has a strong opinion that sort of everything happens maximally in parallel. And so that means that like if you are trying to do a bunch of refactors at once, well, each thing needs its own work tree. Or you need some way of limiting the number of refactors that are in flight at a time so that each one has a work tree that is available. And yeah, I guess I don't have like a super deep answer here. I mean, there are some stuff within Barnum of how we do like parallelism on the Rust side. But like, you're absolutely right that essentially everything's ultimately a parallel problem. And I think the Barnum model makes sense here, which is sort of because everything is maximally parallel, what that means is that any work that is available to be done is being done. And it's up to you to have have the code that will essentially not proceed and do more work if there are not enough resources to do that work. So do you want to run like more than 5 Claude codes, even if invoked with -p at once? Probably not. So there probably should be some sort of primitive that you have that like gives you access to a Claude code and limits that to 5. And Barnum could do a little bit better there. Right now, I'm sort of doing that in userland by essentially limiting it to sort of 2 agents in parallel that generate the refactors and some larger number of agents that like implement them. But in practice, the bottleneck is not that. The bottleneck is like rebasing and landing, and like our CI was not built to handle this sudden onslaught of hundreds and hundreds of PRs. So I'm not super concerned about making Barnum as like making this workflow as performant as it possibly could be in theory. And then there's another reason that I'm not like super concerned about that. I think that the parallelism is important. I think correctness is important. But in the end, like, what are we doing? We're invoking processes that invoke LLMs, and an LLM can take minutes at a time. So like if you have like, so the important thing is running stuff in parallel. It's not like shaving milliseconds off of the invocation path. Yeah, I mean, there's cool stuff I do on the Rust side, but in the Barnum workflow land, it's sort of you just do whatever you want, and I happen to have some patterns that I think work well, but I don't have all of the answers quite figured out yet. Like this works for what I'm doing with it at Pinterest, and I should probably make it more usable in like a variety of other circumstances. But like in the end, like it works well for what I'm doing. So.
Yeah, makes sense. And you won't know what patterns work for other use cases until people actually start using it for those use cases. So a low level primitives make sense until patterns emerge and you find certain things that can be built into the language that, okay, now here's a way to do something that everyone wants to do in terms of
yes.
I was gonna ask you where the framework was going to go, so you guys literally just answered that before I could even ask it, so that's great. I do want to make sure we have time for some of the Isograph thing, so I had just a couple kind of wrap-up questions before we go on to that. It seems like this would be fairly portable if you were to do like codex programmatically, open code programmatically. There's nothing really about Claude code that this is tied to right now. Is that correct?
Exactly.
Cool. That's dope. So have you experimented with those, or for you, Claude code is working just fine? You don't feel the need to try the other ones?
Claude code is working fine. Yeah, I've mostly, once I got it working with Claude, I wasn't super interested in just for fun figuring out how to make it work with Codex, but it should just be the same, right? It's just invoking some process, invoking it, and then enforcing that the LLM responds with some JSON that we can extract from some long stream of text. Yeah, and also like I think to add on to where is Barnum going, there's a few other things that I want to achieve with Barnum. For one thing, like, and this actually gets at why I think code mode is not ideally designed. The way code mode works is that if something crashes and you reinvoke it, then you replay everything. So you have this one file that, let's say, loops over 1,000 files, does some work, and then processes it. Okay, so we did 999 files and we failed to process the 1,000th file. That is going to replay everything. So it's going to reinvoke the LLMs, except it's not actually going to invoke the LLM. It's just going to like pass the data in and it's going to pass it back. And then the JavaScript is going to do extra work and it's going to do other stuff, which is good. And that gives us the advantage that the code that you write in code mode just looks like plain old JavaScript. But it has the disadvantage that everything that touches the outside world has to go through an LLM. So earlier we were talking about listing all the files in your repo. If that goes through an LLM, man, like you're just burning context. Like that costs money to list all the files in your repo in order to, I don't know, find all the JavaScript files. You can't do that with code mode, which is kind of bonkers to me. And secondly, if you are doing a lot of work on the JavaScript side, for example, you list all the files in your repo and you filter them down, every time you replay, you have to redo that work. And so that also means that the JavaScript has to be not idempotent, it has to be pure. So no access, so obviously you can't access the file system. That's why I have to go to the LLM. Two, you can't use stuff like math.random. You can't use stuff like new date and so on and so forth. But like if you're using some external library and it happens to use math.random as part of one of its algorithms, or it does some logging, like it's going to just randomly break. And that's not good. So code mode, like it makes these decisions, which are, I think, make it easier to adopt at the expense of being the correct model. Okay, so what does that have to do with the future of Isograph, of Barnum, excuse me. Isograph is my other project for folks on the call.
Yeah, we're about to get into, yeah.
Yeah. This thing, it describes a workflow, but it is not actually executed on the JavaScript side. So it is a data structure that is introspectable, and it will be executed by TypeScript. But that also means that every single stage in this execution, we know what it is. So if you stop in the middle of a Barnum execution and then you restart, we have all of the information to restart from exactly where you left off. Maybe this assess worthiness was in flight. Okay, we'll have to re-invoke that. But that's small and hopefully contained. It's not like this. It's not necessarily a massive thing. And you can re-invoke, if you re-invoke it, hopefully it does the correct thing. I don't have this in this version of Barnum. Earlier versions had this, and then I did a refactor, and then I didn't choose to bring it back quite yet. But the idea is that you want this to be automatically serializable, automatically resumable. And in that sense, yeah, okay, so that's one thing that I want, that I think is going to be, that is pretty important to actually being able to use this for a larger variety of use cases.
One quick thing I would add there is that crashing, yeah, that's definitely a big use case. But a bigger use case for this sort of like pause and resume is just human in the loop, because sometimes a workflow like halfway in needs an approval from a user. And if I'm away from my computer, I might not see that for like another day or so. So if the next day I come back and I approve it, I want it to start from right there.
Yes, that's a good point. And right now you would do that by just having a loop that sort of pulls, which is fine, but also maybe not the most ideal way to do this compared to just like short circuiting and sort of waiting for some input. Yeah. And then the other thing is that all of these, I didn't actually mention this earlier, but the key thing about these handlers is that they're exported JavaScript functions, and they each run in their own process, in an isolated process. Okay, that's nice because now they can't interact with each other. Sort of everything is sort of as enclosed as possible. And so that specifically means for this case, like, well, we can just re-invoke that function if we happen to crash while assess worthiness is, oh, Jesus, I have to figure out how to disable that garbage. And in particular, well, the way we invoke those is from the Rust side. We invoke a process that calls node or calls PNPM or calls whatever, and executes that little, that JavaScript. And okay, that sounds, what's special about JavaScript? Nothing. So we could also allow you to invoke Python, Bash, whatever custom runtime for invoking Claude or something like that, sort of more directly as part of this. Yes, exactly. Yeah. So in particular, it sounds super useful for doing stuff like orchestrating your Python, like your ML workflow, in a way that is accessible to folks that are more used to JavaScript. Or, I mean, there's also nothing special about this. Like all we're doing here is some light transformation, generating an AST, and then serializing that and sending it to the Rust side where the real work happens. Like this is actually super simple. Let's take a look. Do I have Barnum? If I have, let's see, Barnum here. Let's see if we have this constant. Oh, that's not a JavaScript file. Those are Markdown. Okay, I think I can go to definition here. Yeah. See, it's really
Don't you
simple. It's just
Zed dev.
I'm very new to Zed, as you can tell. So this constant function, which just happens to be one of the things you can do, it just returns some AST thing, and then that gets generated into some sort of tree that gets composed and whatever, and sent, serialized and sent to the Rust side. Nothing about this is specific to JavaScript, so we could just as easily have a DSL in Python, a DSL in whatever your language of choice is, in Ruby even, and it would work just as well.
Or a completely custom DSL.
Yep. Actually, I do want custom stuff. That's one of the things I do want ultimately, but you got to pick your battles, so.
Use your technical innovation tokens or points. Someone had a term for that. You should only bet on one big new piece of tech per project. If you bet on too many, you use your innovation tokens. I think is what they called it.
Mm-hmm.
Yeah, I never follow that. I always every time I have a new project, I pick 3 to 4 new things that I want to play around with, and
we got a question here, and then after this, I do want to go to the Isograph stuff to keep us on track. So I don't get why we need AST step. Why do we need Rust? It could just be running inside TSS node. And while you do that, I'm gonna just use the bathroom real quick. So
yeah. So the reason we want to use Rust is that Rust it makes it easy to actually write code that is more correct and more trustworthy. And there's sort of two aspects to this. On the one hand, there is this layer here where this is invoked sort of to construct the AST, and then these handlers are run in separate processes, and then there's something in between. We could, in theory, just do this entirely in JavaScript, but I think if we did this entirely in JavaScript without at least having an intervening layer that called a bunch of processes in their own, a bunch of handlers in their own process, well, then everything could sort of reach out and have whatever side effects they want. And if you have whatever side effects you want, then you kind of struggle to have the guarantees that everything is actually correct in the way that you want. But that being said, obviously Rust and JavaScript and everything else, it's Turing complete, and you can sort of do whatever you want in whatever language. So I think the most important part here is that there is, one, I like Rust. I think it's a great language. And two, the disconnect between the runtime and the invoked handlers and the isolation of the handlers is somewhat important. At least in theory, that's important. Mm-hmm. Yeah. So.
Yeah. I think that makes sense. I think the focus of the question was probably not on why Rust, but more on why does there need to be an intermediate step? Why do you need a step that constructs the AST and another step that interprets or executes that AST and then calls out to these external processes, rather than the workflow itself being a Rust or a TypeScript function that gets executed dynamically. And so you're saying that the isolation between the orchestration and the handling is important. And I think one of the reasons why that's important is the pause and resume thing that you mentioned earlier.
Mm-hmm.
You just cannot do that in vanilla TypeScript unless you introduce I guess more syntax of some sort, or use workflow, use step that Vercel has, and then you add a custom compiler there. But you can't. Yeah, I think maybe that's one of the reasons. But yeah, that's
yeah, that's right. I think the isolation is not easy to. Well, yeah, you need the isolation for the resumability and just for ease of reasoning, and because. Yeah, I mean, that's basically for that. I mean, you also get some other benefits from the isolation, you can have higher order functions really easily. So retry this thing 3 times. That's a really easy thing to do, and it sort of wraps whatever you want. And it doesn't necessarily know anything about what's happening on the inside. is kind of nice. But yeah, I mean, the real answer is like, I like Rust. I think that this is it's a pleasant way for me to ship a lot of code in a small amount of time. With respect to Temporal, this is also really similar to Temporal. I think it has better, some better properties than Temporal. For example, I think composability in Temporal is not very good. I think it's really hard to do stuff like have higher order functions, retry things, and have the actual behavior that I want. So in particular, this loop thing here, this gives us a function recur. And whenever recur is encountered, well, it has a return type of never. Whenever it's executed, well, then we tear down this AST and we re-execute this AST in this case. And so we dequeue another file at that point in time. So recur also occurs here. And so if I, for example, like move this up, well, then, I mean, it still continues to work. And I can pass recur to some sort of like wait 5, sleep, then, right, recur. And that will just work. Like recur is just a value that gets passed somewhere else. And so on and so forth. All these kind of things like I can do because I made a very specific, deliberate choice. And I think that many of these other libraries, Temporal, they have more users because what they're doing is more approachable, but it limits the ceiling. And I'm not necessarily building a business out of Barnum. So I'm okay with
Temporal also like a whole platform. Like it's not just a library, right?
Yeah, yeah. And that's probably where the money's at. It's like doing the replayable work. I don't even remember what the term is. Durable execution.
Durable execution. Like durable.
Yeah.
Yeah. I only know about this because Swix worked at this company for like a year. And so I used to always listen to every interview Swix would ever do. So I heard her talk about Temporal for like a whole year. And I'm like, this is solving a problem I do not have.
Yeah. But yeah, so that's Barnum. I do hope folks try it.
This is very, very cool. I will definitely try it out because I got lots of refactors I always want to do. Let's get into Isograph a little bit. I looked at the docs and I'm like, I see GraphQL queries and it's being fed into some sort of React-like component syntax. And that's pretty much all I need. Like I'm sold.
Nice.
There's nothing about this that would confuse me because this to me is just how all programs should be written forever.
Yeah. So Isograph, I guess like let's take a quick detour to talk about GraphQL. What is nice about GraphQL? What's nice about GraphQL is that you have a few things. Is that you have fragment-like you have composability. So you might have like a homepage or a user detail fragment. And in there, you might spread the user avatar. And that means that whenever the user avatar fragment, and whenever you modify the fragment, for example, you might add the email or the image URL or the ID or whatever. Well, that gets sort of automatically added to the parent fragment, all of the parent fragments. And ultimately, that bubbles up to a bunch of queries. So you essentially are able to define, and each of these fragments is associated with one component in your code base, ideally. And that means that when you modify one component, you can modify its fragment to have exactly the fields that you need locally, and no more and no less. And that automatically bubbles up to whatever queries, and these queries will fetch exactly the data that happens to be needed by the current configuration of your page. So you can reason locally and everything ends up being correct. Now, if you have something else, let's say TanStack and REST, well, you kind of have some bad options. So for example, you're modifying some sort of deeply nested component. If you add a field, okay, I mean, it's not so bad. Now you go find whatever queries and add like the email field to those queries, right? And maybe that's like selecting it from REST. Maybe the backend now has to start returning email. I don't know exactly what it is, but you make some change and you start getting email. But now if you stop using that email field, well, that's tough because now you have to go to these queries, Remove the email field. Maybe you have to kind of do some research to determine, is any other subcomponent in the tree using that email field? And the answer is nobody does that amount of research. And so queries get bloated. They get filled with fields that are not used. Okay, most people will look at that description and say, that sounds theoretical. That sounds like a big company problem. I only pass data down a couple of layers. And that's also a problem. You have like limited the amount of complexity that your app is able to absorb. And you are prevented from breaking up your components into smaller and smaller parts, even if that's the correct thing for your particular use case, because you need to be able to reason about an entire tree in your head at once. So once again, all non-relay, non-isograph frameworks make the wrong trade-off. They sort of limit your complexity and make it so that if you try to do the right thing, you are overwhelmed.
So real quick, what would you say to someone who would say, that's all great, but I already know how to do REST, and the overhead I'm going to get from GraphQL is not worth solving that problem for me?
I think it depends on the situation. You, for example, might come back from a week-long vacation, and you come back to your code base, and in the meantime, dev has made so many changes to it, and now you don't know what it's like. The reason that worked before was because you or some other code owner understood everything. But now changes have been made and you don't.
Yourself, yeah.
Yes, exactly. And the same thing could be said about Git. Okay, I'm the only person modifying this repository. I don't need these fancy branches. Like, what's the point of that? But you still want to use Git and the reason is that even though you are not multiple people, you are multiple people, one person in the morning, and then you've forgotten what you're doing on the evening, and then whatever. And furthermore, the developer experience cost of using Git is so low that it's worth it even on single person projects that have a linear history. Same thing is true for GraphQL. You want to be able to reason locally when you modify components and not load the entire code, all the code into your head. Okay, loading code into your head, that's using context. Okay, context is expensive. If you are an LLM trying to make changes, the less you have to reason about the entirety of the code base, the cheaper and more reliable and better. So there's a lot of reasons why you want to use GraphQL.
And LLMs are where they work better when they have a schema to go along with. There's some sort of thing that can guarantee, different types and how it can understand the whole architecture and how it all fits together. So like if you could point at an RFC or something, or like a spec like GraphQL, then there's a whole set of things it already can figure out how to do within that world of that convention.
Mm-hmm. Yes. Okay, so now we're going to jump a couple steps forward. Why Isograph? Okay, so with GraphQL, you have fragments, and each fragment is associated with a specific function. So you have like this user detail avatar, and it reads the fields that are needed by the user detail component. And that has to be a one-to-one connection, because otherwise, maybe you're overfetching or you're underfetching. So you don't want to reuse fragments, despite what Apollo's docs will have led you to believe, and so on. You don't want to reuse queries. You want to just have exactly the one query per screen, and it composes correctly based on all of the things that are in the screen. Okay, so if the user detail component, I'm, by the way, just like on a random page here. I wasn't actually thinking about whether this is the correct, maybe Quick Start Guide has a simple example.
Yeah, you should just pull up even better would be just like the GraphQL.com fragment like a page, just so people can get a sense for, because if you don't know GraphQL, like a fragment itself is a very specific kind of part of it, because you have queries and mutations, but fragments is kind of how you can compose different GraphQL queries together, right?
Yes, exactly. So there we go. We'll do this. Repository link. Okay. Perfect. So in particular, maybe you have a this is actually in our like internal GitHub demo on Isograph. if you have a component, a repository link component, this function right here, that happens to read some sort of, essentially you can think of this as a fragment for now. So there's some fields on repository, which is a type in your GraphQL schema. You might read the name, ID, owner, login, whatever. Well, there's a one-to-one correspondence between the fragment and the component that uses that data.
Right, yeah, because you're pulling out these specific things with the GraphQL query. Each of them is going usually to some sort of like HTML fragment to have it compose with a component. That's why it fits so well together with something like React.
Yes, yes. Now, with every framework except for Isograph and to some extent Houdini, which is another great framework, that component, the fact that one function reads a particular fragment is not known at compile time, and you can't take advantage of that. But on the other hand, with Isograph, we know the fact that this repository link component reads this data. This is exactly one thing for our purposes. So in particular, if you search for repository link, and I don't have the language server installed. I actually haven't done anything with Isograph on this new computer yet. You'll notice here that we have this parent. I don't know what this parent is, but it's some sort of GraphQL field. And we select the repository link on it directly. Now, the GraphQL schema does not have this repository link as a field on it. But because we defined this repository link here, we can now just directly select it. So now conceptually, what are you doing? You're starting with a home page. You're selecting the body. The body might have a current blog post. The blog post has a blog header. And you're just selecting all these components through the field, and you just receive them. And they're already pre-bound to the data that they end up using. So here, this repository link, what do we do with it? Again, forgive the syntax errors because I haven't run. I need to run the compiler in here because it generates a bunch of files. And in this repository link, in here, parent.repository link, that's a component that happens to know about all the fields that it selects. And so here, what if we change repository link to select some other fields? Well, nothing here changes. We're not passing any data down, but it happens to know that closes over those fields. Okay, we do pass set route. That's not part of the graph data. That's just a regular prop that we define here. And so that's nice. That means that you can essentially define your entire app as like a set of nested components. And each of these components close over the data that they happen to use. And this, just like with GraphQL, generates a query for all the fields that are needed by a given page. So let's just search for queried text. So on our Pokemon demo, this generates this query. And this is sort of what is executed.
Grabs Pokemon, which includes the form, key, number, species, and the sprite image.
Yeah. And yeah, so this is like the query that is actually executed at compile time. And not at compile time, but actually executed when you run the page. Yeah, and this will get all the data.
Throws a string over to the GraphQL endpoint.
Exactly. And then this at runtime will, basically we generate a bunch of files, which you don't need to look at, but they're just these JSON things. Let me find a slightly better one. Yeah, cool. It's a bunch of JSON things. It's this AST. And using this AST, what we're going to do is when we read this pet updater, I know it's small, when you read this pet updater component, it will use this AST to read out the fields that it knows came back from the network response and render the components that we're talking about here. So that's a lot of technical description. It's not super. Let me actually talk about why this matters. Well, one, there's no way to mess this up. You can make whatever changes you want to repository link, and nothing has to change anywhere else. You don't have to reason globally. So that means you or an intern or Opus, Haiku can reason about these And like, you don't have to be that smart. You can just make the changes. And everything just continues to work. There's just like so little boilerplate compared to any other framework. Secondly, there's some advantages to these two being associated at build time. So for example, if you defer the data for some subpart of your tree, like let's say you fetch the blog post and it takes a long time to fetch the comments section. So you defer that. GraphQL has a facility for essentially fetching that as essentially a follow-up network response. In GraphQL and Relay and every other framework, like if you're going to defer some data like that, well, then you need to manually also probably asynchronously load the JavaScript for that components thing. But because we know at build time that the component JavaScript and its data are both, well, there's one place where you can defer them both. And thus, if you search for something like Loadable, lazy load artifact true. If you do this, well, what just happened? I want to do this. This is like a bunch of tests. But if you happen to do this, well then, this is a broken test because it's showing some sort of broken state on purpose. This image display wrapper here, this image display, the data for that image display component and the JavaScript will be asynchronously loaded when we render this component. So that's like one of the benefits of being able to connect these. But there are more benefits. There are lots of benefits. One of the other benefits is like, imagine your large company code base. How many user avatar components do you have? Probably like 50 gajillion. And the reason for that is because it's like not really easily discoverable. And so you have so many duplicate things. But on the other hand, here, if you are on a user and you start typing .avatar or something, it'll just suggest that for you if we have the language server installed, which is not installed. So therefore, it will cut down on essentially duplicate components, and instead you will be softly pushed into having the one right user avatar component that actually works for sort of all the use cases. Yeah, that's the spiel.
Thanks.
Yeah,
cool.
So things like at loadable, those are directives, right?
It looks like a directive, but it's really a nice graph thing.
It's really a nice graph thing. Okay, yeah, that was the thing that is mainly makes it different from just pure GraphQL, because you're not just sticking to the spec, you're building things into it. So they're kind of GraphQL-esque queries, but they're not exactly the same.
Yes.
Or at least it's like a superset, like all the GraphQL behavior with some added syntax, kind of like TypeScript is with JavaScript.
Yes. So for example, this blog item here, like this image display wrapper, it's a field that we're selecting on image, but like type image here, it doesn't have that field. So we're augmenting the schema with a bunch of other stuff.
Right. Yeah.
Yeah.
And the things you add to the schema, it's not just data, it's UI essentially. So when you fetch, when you write or when you execute a GraphQL query and you select those fields, you don't just get JSON, you get a React component that you can just return from the React component that fetched that data, and you'll have the UI for it.
Yes.
Which is pretty cool.
Yeah. So this might get a little bit in the weeds. Okay, but one of the things that you might notice about one of the things about GraphQL is that in theory you should not be removing fields from the schema. You should only be doing you should not be doing backwards incompatible changes, of which removing a field is one. Yeah. Now, you also have an issue where, let's say you have a user, and then you have this user's favorite restaurants, right? Okay, so the way you would define that is a field called favorite restaurants on the user. Okay, right? Oh, well, what if we have like user's favorite restaurants in a given city? Okay, so now we have user, and then we have city, and then we have favorite restaurants on that like weird combination of like stuff, right? But like, okay, so maybe this is hometown, right? User, hometown, favorite restaurants, right? And like, if you look at that, why are we doing this? Well, the answer is that if we were to fetch the user and fetch their hometown and then fetch the restaurants, that would be a network waterfall. And GraphQL's raison d'etre is to avoid network waterfalls. So you end up structuring this as part of the GraphQL schema. So you have the user and then their hometown and then favorite restaurants in hometown on user. Okay, right? But like, that's also really awkward because, well, now it's not really favorite restaurants on a hometown, on a town. It's just, it's the users. It's some tuple of the user plus the hometown. And then favorite restaurants on that.
You take on a lot of complexity into the schema for the sake of the simplicity of the query.
Yes, and for the performance of it. Now, why do we want that? And the reason is that some particular version of some particular product wanted to show you the favorite restaurants in your hometown because it's hometown celebration month on Yelp.com, you know? And okay, only web does that because web iterates faster than iOS and Android or something like that. Who cares? But this extra cruft gets added to your schema and it's 1, visible to Android and iOS. 2, it's useless on their thing. And 3, it is specifically serving the specific needs of a specific UI. Okay, how do we add fields in a particular repository such that it is only accessible in a particular piece of UI? Well, that's exactly what this is. This repository link does not get added to the schema in the abstract. It's visible as part of this Isograph project. And if this Isograph project no longer wants to use the repository link, well, then it kind of disappears. Next version doesn't have it. Okay, now this executes on the client. Okay, repository link is a component. Maybe it's not the best example, but I think we have something like formatted date. Okay, just imagine we have a formatted date. It somewhere exists. I just don't know what it's called.
It takes a JavaScript date, turns into, y dash.
Exactly. Yeah.
Year, month,
okay.
date.
It's nice to define that in as if it was a client field, just like these. But it would also be nice to execute that on the server. And so the next thing that Isograph will be doing, I mean, in theory, I mean, there's too many things for me to do with my limited time. But one of the things I want to do with Isograph is to allow you to move the execution of this thing onto the server. So now you can do exactly what we just discussed, the favorite restaurants in your hometown. You can define that in localized to a specific project. It can execute on the server for performance, and your Android and iOS teams are none the wiser. And then when you modify things, well, whatever, it changes. The next version has a different version of hometown favorites, you know? Yeah, so that's the idea. And the net effect of all of this is that your app is a tree of, is like this DAG of stuff that needs to happen. And Isograph is, I think, a pretty good way of expressing this sort of DAG-like, tree-like workflow. And if you have this tree, you sort of can look at it in multiple different ways. One way is like some work gets hoisted to the server. Okay, that's kind of like React Server Components. It's just basically what I described, except React Server Components is a bunch of limitations that this gets to avoid. It has another benefit, which is that there's a big company behind it. So, you know, there's trade-offs. But in theory, this is a better model.
You can also do things like give API keys or stuff. Like you can do queries that can do other stuff if you're running it on the server. Because this was the thing that when I worked at my GraphQL company, StepZen, it was a hosted GraphQL endpoint, but it would be locked down from the top. So you'd have to run your GraphQL queries in like a serverless function. And so that would kind of push you to doing it on the server. But then you would think a lot about your actual query and then get the data you need. And like you say, then you get exactly what you want for each page.
Yes. Yeah, that's exactly right. Like you have there's a lot of stuff you can execute on the server. Maybe secrets. Maybe you want stuff moved up there for performance. Maybe you have, and also maybe the backend thing is written in a different language. In this case, okay, so what are we doing here? When we reference this image display, we're saying from the perspective of this image display wrapper, okay, this is loadable. So like, let's just talk about a simpler example. This image display wrapper here, we don't know anything about it. All we know is that there's some function that has some return value. Well, whatever, we have a return value. Happens to be a component, but like, let's just say it's a string. Okay. We don't care how that string was calculated. We don't care where it was calculated. And so and all we're doing is we're saying we want this particular string. What if that function, what if that image display wrapper was written in Python? Well, it has to execute on the server. The server is the only one that knows how to execute Python. But we could now intersperse, again, because of that isolation that we talked about earlier, a lot of work in sort of a tree-like thing. And yeah, anyway, so I'm going to leave it there, that there's a lot in common between both of the projects.
Yeah, no, that's very
definitely
cool. And this is being used at Pinterest right now, you were saying?
No. There's a startup that's using Isograph. Barnum, I'm using Barnum very extensively at Pinterest to ship a very large number of PRs. And I've some other folks at Pinterest and elsewhere have used Barnum. But like, I haven't really focused yet on the marketing. I haven't really strongly focused on marketing it yet. So,
okay.
So like
who's using Isograph?
This company that is called.
Also, one of you two right now, there's a like radio bleeding through or something.
You better go ahead and guess that that's not me.
Yeah, that's Dev.
Yeah. Bolt Foundry. There we go. This company is
I've heard of Bolt Foundry.
What? You know them? That's so cool. Yeah.
They didn't. Okay, hold on. Bolt Foundry hosted GraphQL Texas, didn't they?
Not sure. They're based in New York and Utah, as far as I know. But let's see.
There's
maybe, for all I know. Yeah.
They hosted a GraphQL meetup that I did. It may not have been Texas because I did a bunch, but that is why I've heard of Bolt Foundry. So yeah.
Yeah. They're very happy users of Isograph, and yeah.
There are so many interesting things about GraphQL that I would, not GraphQL, GraphQL as well, but Isograph specifically, that I feel like I could talk about for forever. I think the way that.
If you wanted to come back for another episode, Robert, that we could do all on Isograph, that would be great. We still have more time, but just saying, throw that invitation out there.
Oh yeah, we'd definitely be happy to. Yeah. So.
Yeah. Go ahead, Dev.
Yeah, I mean, in specific, I think the way that the way that you decide to compose queries and components together, that feels very nice. That there kind of eliminates so much of boilerplate. Like, it's not a framework that comes with a bunch of hooks that you need to learn how to use, or like custom components, anything like that. Am I still okay? Yeah.
Yeah, you're still.
Sorry, yeah. And so, okay, one thing that I was wondering is there, you mentioned that there's a build step that kind of like goes through your routes and compiles together like one giant query that can fetch all the data for that page. I'm guessing that compiler like literally goes through your React components to look at, like, does it have to look through your React code to see what components you're rendering, or just this query?
No, it's pretty dumb in the sense that it looks for Isograph literals. And these Isograph literals are matched with a regex. So it looks for literally exactly this, and then it attempts to process them. And then it also makes sure that it checks like a very small amount of other things. And so it's basically looking for this pattern here. But it doesn't know anything about JavaScript. And then there are lint rules. So these lint rules will enforce that this is, well, are there lint rules? No, there are no lint rules. No, they're not. There should be. Anyway, we also enforce that this is exported and so on and so forth. So there's like there are limited things that we do enforce to ensure that this is done correctly. But in terms of understanding JavaScript, not at all.
Got it. Okay.
So yeah, you could, for example, fool this by doing something like like this. I mean, that actually is not a multi-line. Okay, whatever. JavaScript doesn't have multi-line things, but like, whatever.
Yeah. So it sounds like something that that might not need a build step, or am I off here?
Oh no, it needs a build step. It will, I think I will not be able to find this because it's not in whatever Z marketplace there is, does not include the extension. TIL, we should publish it in a bunch of other places.
Not surprising to me.
Yeah,
that's
so
one of the big limitations have said.
Yeah, this is converted into a bunch of files. So in particular, that resolver reader that we talked about, so it's going to have this author and title and content fields and so on. And this blog item more detail is on there as well. It will also generate a this param type here. So basically when you add and remove fields from this gets modified. And so now if you hover on this blog item thing here, you know that you have these types here. And that can't be inferred from the JavaScript. I mean, that can't be inferred by TypeScript. Like, I'm not going to try to go down that route. I don't think it's a good route.
Right.
It's technically impressive to do that, but like, no.
Like building Doom in TypeScript only at the type level.
Yeah. Yeah. And what's also interesting about this is that, like, I mean, it isn't anything that a backend knows how to execute, but we still have this query text here. This other query text that, like this one, right? Right. Okay, that's a pretty boring ass query. But like this thing is generated also.
Right.
And one thing that's nice about this is that, so one of the benefits of GraphQL is that you have fragment-like composition, but there's no fragments to be found anywhere in these query texts. We have done the inlining ourselves. And so that means that we are essentially doing fragment-like composition in user land. So we can, instead of generating GraphQL here, we could generate SQL, we could generate TRPC, we could generate your custom backend code that says like, hey, db.getNode.getTypeName.getID, whatever, like, and then package that up and generate it for you. And Isograph is written in a way that is generic in the sense that there is an interface that we implement that knows how to generate GraphQL. And there would be we just have to have another interface that we implement that would generate SQL or would generate whatever custom backend stuff that you want. And then again, we're not sending this. Well, there are two ways to do this. One is you can send this string to the backend, which is sort of the easy no build process kind of way. But the other one is that you would register this at build time, get an ID back, and then you would send that ID at runtime, and that ID will the backend will look up that ID in a database or something, execute this, and send that value back to the front end.
It allows you to create like a level of indirection between the actual GraphQL query and how the front end accesses it.
Exactly, and it adds security because, like, if you accept any arbitrary GraphQL, well, then you could have something that sort of DDoSes your backend.
Right. Yeah.
Or exposes information that you don't want to expose to users, but it's part of your GraphQL schema, and oops, nobody noticed. So
nice. Yeah, I'd be curious to see this. I'd be curious to see this work with some sort of a sync engine, maybe, where the same query can run both on the server and on the client. And when you receive any data from the server, you also store it on the client side, so you can do like instant navigation. I guess a Relay kind of does some of that. Like there is a normalized cache. What is like the caching and optimistic story, if you have one, in Isograph?
Yeah. So while I figure out how to install PNPM and so on, I thought I installed PNPM already. I guess I haven't. I mean, this is a really new laptop. So in Isograph, you have essentially, did it work? Command not found PNPM. Why? It's probably not in the, it's probably there, but it's not in the,
You might need
in
to
the
restart
path.
the terminal or something.
Yeah, let me try. That's a good idea. Nope, still not there.
Nope.
Not in the path. Yeah, okay. Weird.
npx PNPM.
That's what I needed to do. Okay, so Isograph has a normalized store. So everything that we get from the backend gets keyed by, that's keyed by ID, gets put into a normalized store. And then when we actually read the data, we read the data from that store. So there's sort of two separate processes. The network responses right into the store, completely coincidentally, reads from that same store. And there is we hope that the responses give all the data that we need for the front end, and it happens to work out in that way. But that's not like structurally guaranteed. And this means that we can do a lot of really cool things. So for example, in Isograph, like in Relay, if you try to read a component and some data is missing, it will suspend. And so that means that if you navigate from a list view to a detail view, well, maybe you have enough information. Fine. God damn it. Maybe you have enough information. You know, it's not that Isograph is hard to run. It's that I don't know how to install PNPM.
Hey, if Claude Claude cannot also figure it out, then it's probably you're fine.
Yeah. Yeah. I think I just need to add this to my ZSharC. So, okay. So if you navigate from a list view to a detail view, the outer component, let's say the one that shows the title of the detail view, will already have enough data inside the store. And so it can immediately render. And if you wrap the rest of the content in a suspense boundary, I give up. Then you will immediately render the upper part, and then the bottom part will suspend, and you'll show a spinner there. And then eventually it will pop in. So yeah, so there's actually a really good story here, but it actually goes beyond just the naive thing, which is what I described is also in Relay essentially, and possibly in other frameworks as well. But one of the things that you know about Isograph is that you have this DAG of work that is being done. And one of the things that we are sort of doing but not fully, and the way it will work is that ultimately you will have everything in all the pre-computed stuff is stored in the Relay store. So for example, the formatted date, that is some sort of function that depends on the actual raw date. And then you have something like the current day display clock, right? That depends on the formatted date. Okay, so when the underlying date changes, well, then we recalculate the formatted date. Okay, but maybe the formatted date doesn't show the year and only the year changed, or whatever. It doesn't show the seconds and it only shows minutes, right? So now we can short circuit and we don't have to re-render the clock, right? Well, okay, maybe the clock shows seconds, but whatever. The milliseconds changed and the seconds didn't change. So we can short circuit and re-render the clock and not re-render the clock. And the whole thing will be like this tree of work that we have calculated, and we will try to calculate the minimal amount of work that needs to be done in response to changes to the underlying data. And that is kind of a universal problem. A lot of what you want to do is the minimum amount of work. The way you make apps be performant is you do less work. It's not that you get better at doing the existing work, it's that you figure out you're smarter about doing less work. So you have to keep track of what goes into what flows into what. And that's how with Isograph, like when you make a change to something or other, you'll only see the components that actually need to re-render actually re-render.
It sounds like the perfect framework to pair with Isograph is not React, but Solid.
Of course you would say that, Dev. Solid JS. Team member, undisclosed affiliations.
Yeah, I don't think you're wrong. I think that what's nice about Solid, there's a lot of nice things about Solid. And one of them is the fact that it's like a little bit more stateful, like the components actually have are constructed once. And that corresponds really well to what Isograph is doing. In React, like you have this idea that the component can render any number of times before it mounts. And that's kind of like a constructor, but it's also really a problem. But on the other hand, with Isograph, we know, because we know that there's a query root, and this query root can reach the blog detail component, that this blog detail component needs to be constructed. And it can be changed and modified and handled by the framework. So that's the idea there, is that we have more hooks than React sort of allows you to do. It's sort of like the class version of React would have been a better fit for Isograph. I mean, it works just fine because the rendering part is relatively small. But like it did it. Okay, let's see. Let's see. Wow, that's so fast. How did it like, oh, probably because I already had the things in there. Okay, so let me just take a look at the thingy. I think.
Yeah, it might have run pnpm install earlier, which means you have everything cached.
Yeah, it probably did. It right because okay, so we want to do pnpm dev pet demo, named after our favorite host, and this will build a bunch of stuff in Rust. Did you catch all that? So anyway, so then yeah, we're mostly building the Babel, not the Babel plugin, the SWC plugin. And what are we?
Of course.
What are we complaining about here? Cannot find. Oh, I need to add the target. Let me just. That didn't even copy it. Okay, so I just need to add wasm 32 wasip 1 target. See what the thing is. We don't even need that because we only need that when we're changing it. We don't actually need it to run the thing. I could be a little bit better about not requiring that. Yeah, so eventually this we'll get there. So that's the thing. If you work on a project, you don't know all the steps that are actually required to bootstrap it.
It's just running. Yeah. It's been running on your machine for so long.
Exactly. And at some point in time, I installed that. Okay, cool. So it should be doing that, and then it should work pretty well, pretty quickly. Cool. Target installed. I believe it. Okay. And yeah, and then we can actually like show off some of the.
Yeah, but I understand the point that it's Isograph does a lot of work in that goes into making a React app performant, to kind of like reduce re-renders and to because basically if you have a component and you know exactly what that component depends on, what data that component depends on, and you have that in a normalized store, when that updates, you can go and re-render exactly those components, instead of like you don't have a top-down tree, a top-down like tree re-render where one component re-renders and all the children re-render, and then the only way to put a break on that is like memoization.
Yes,
this is like almost like an additional layer of memoization.
Yeah, it's actually
nice.
it's smarter about the memoization too, because what that didn't even that was not even correct. Because it has more information than is known at runtime, right? It has the ability to look at a bunch of stuff and throw stuff away, and do the right thing despite not needing that. Like one of the, so it's very similar. I don't know if y'all have seen Fate. Fate is something that Christoph Nakazawa has released, and it is similar to Relay. It's similar to Isograph, but it does that sort of at runtime. So you actually have a data structure that does all this stuff, and that allows you to do, that allows you to do a few more things. For example, dynamically construct queries for just the fields that are missing. But on the other hand, it prevents you from doing more stuff at build time, which is, I think, the trade-off that Relay and Isograph try to make. Yeah. So let's see. I have no idea why these build things are failing. Oh yeah, it's because there's a newer version of I'm on a newer version of Rust.
SWC.
Okay. Yeah.
Rust.
Downgrade, okay. Rust. Yeah. So as you can tell, new versions of Rust are released, and I have to make changes as a result. Yeah. And so what's nice about this is that, like, you have some bad trade-offs in React. You, for example, need to specifically break your components up into subparts in order to theoretically get some of the performance benefit. Okay, same thing is true in Isograph. Like, if you want to have that memoization layer between the formatted date and the clock, well, then you need to have a separate formatted date thing, and the clock can't read the date directly. One of the things I want to do with Isograph is essentially have a way to encode more functionality into the query itself, so that at build time we know that the formatting occurs and it flows into the clock, and you don't need to do anything. You don't need to say, like, I mean, you can just kind of do it in the natural way.
Yeah. Are you kind of talking about, like,
yeah, but so you would dynamically
breaking apart components at build time?
Yes, exactly. Because you're able to encode more of the logic inside of the Isograph literal. And you want it to focus on sort of not everything. So you probably want it to focus on, like, control flow and filtering and things like that, because otherwise you go down the path of reinventing a version of JavaScript that has different semantics but is, like, equally complicated, and it's going to be very hard to integrate with other stuff. But yeah, that's one of the ideas that I have about that as well. But in general, you can be much more aggressive about caching with Isograph, because because the natural thing to do is to have these intermediate things, like formatted date and stuff like that, and then they become these sort of memoization boundaries. All right, it says it worked. Let's see if it works.
And I can go for another, like, 10 or 20 minutes, but I have to start wrapping up soon, so my workshop starts in a half hour.
Oh, excellent. Okay, I won't keep you long. Let me show. Let's just do one final demo.
And Dev, you should also, if you have any kind of final wrap-up questions. For me, I would just the only thing would be share, like, your socials and where people can get in touch and learn more.
Can't find Isograph React.
Yeah, I probably just needed to run npm install. Why is it not finding it? It should be finding it. I thought it would run this by. Oh, I probably need to run build. There's like another. One of these other ones needs to be run. Actually, let's just. I don't remember where exactly it is. Is it here? No, it's here. PNP.
Like a monorepo structure you're in?
Yes. I need to build the JavaScript. Watch libs, that'll do it. Yeah. Okay.
Right. So this is the monorepo with Isograph itself and some demo applications. Right.
Yeah.
Yeah, now I should be able to find, because I'm guessing Isograph React points to a version of the local package. Nice.
And, got your query, got your cards.
Yes.
A bunch of pets. Classic GraphQL demo.
Exactly. Okay, so let's go ahead and add some delay here. Let's just say
this shit makes me so nostalgic. You guys have no idea. I haven't done GraphQL in like 3 years.
Nice. Okay, so let's go ahead and give it 1,000 milliseconds of delay. Okay, and then close this out and I called it 2 seconds of delay. So now we have loaded the like Michaela's name and image. And so when we navigate here, you're going to have a 2-second delay. Well, one, it has to get the JavaScript, and then it's going to show the top. And then, oh, that's interesting. Oh, let's try that again. Not sure why that happened.
Yeah, what you want, loader.
Yeah. So you notice that it showed the top first immediately, and then the bottom, even though the server is running locally. This takes exactly 0 seconds in practice. But now if we press back, well, it goes instantly. The images re-download because I guess it's Next.js and has images are not really, they're not Isograph's problem. And if you go back to this demo again, now everything's going to load immediately, even if we were to make another network request in the background. So now if we go here,
like state file to validate.
Yes. Well, you can opt into that. Yes, you could do that if you wanted
to.
But it's sort of up to you, whatever you want. So here, if we go to, I don't even have the React DevTools. That's how new this computer is. Item is inactive. Enable now. Re-enable. Okay. So here, if we have do we have the React DevTool? How do I enable them? Where do they go? No, I don't know how to do the React DevTools.
React DevTools in a while.
Yeah, they're enabled.
And like dev, I went over to the dark side. Solid.
Yeah. Okay, well, in theory,
it might be an application. I think that it's now moved into some other tab. I don't know which one.
Okay. Application?
Who knows?
Or not? No. Okay.
I thought it was.
I was remembering something else.
Yeah. Anyway, whatever. If we were to show that, then if you were, for example, to change the best friend here, none of this stuff would re-render. None of this, all this other stuff down here. It would just show the new one here. And here, if you touch this, it will just re-render this exact specific component, despite all of these components reading from the same object, essentially. And theoretically, I mean, if you were to do this as a React component, you would thread data down from the root and pass it to every child. And so that pet has changed because now its check-ins have changed and its its best friend has changed. So you would pass that data down, and everything should recalculate and re-render. And that's incredibly costly, especially if you're paginating and you have like hundreds of items. Like the first couple pages might be performant, and it gets slower and slower and slower. And with something like Isograph, you just re-render the components that actually have changed. So it ends up staying snappy.
Nice.
Yeah. I think that's a good place to end it.
Yeah, no, very cool, man. Thank you for coming on and sharing both these projects. Very, very interesting. And it's great that they're open source and that anyone can try these out. So that's what we're always all about here. Why don't you just share?
Except that they're both in Rust, which means you need a PhD before contributing.
Not with the agents, buddy. It'll write whatever I ask it to.
Yeah. So worth learning Rust. I think it's a great language.
Mm-hmm.
I would encourage y'all to learn it. So.
All right, so you're at x.com/statistics for the win.
Yes, exactly. Let me show that. Can I jump to my profile? Yeah, here we go.
Yeah, and then I think I've got FDW. Links to Isograph and all that stuff I'll have in the description of the YouTube video.
And what would you say is the easiest way for someone to use Barnum? Let's say I used Codex right now, and I'm kind of tired of long sessions or short sessions, and I want to adopt Barnum to do refactor work, to do automations, background, whatever. What would be do I just go to Codex and say that start using Barnum on this project?
Yeah.
Or is there like a skill.md file that teaches agents how to write Barnum?
If you point Barnum, if you point them to this best practices doc, it does a pretty good job. I mean, this is basically every single issue that I've ever encountered when asking it to do stuff. So I just have it look at the best practices and read the docs, and it tends to be after that pretty good. It tends to be pretty good at that point in time at writing Barnum workflows.
Can you add .md to your URL and just get a markdown page?
I should do that. The answer is no.
Okay.
Which is low hanging fruit.
Is this Docusaurus?
Yeah, it's Docusaurus. Oh, so maybe we do have it.
I know a Docusaurus talks out when I see one.
Yeah.
No, that's great.
Like, why go off Docusaurus? It does exactly what I need. You know,
I know Sebastian, and he's super cool. So
he's really awesome.
Yeah.